Hello students, my name is Priyanka and I'm your science teacher. So, today I'm here to start with the chapter number 15, that is light. So, let's study about light. Rays and beam of light. A very narrow path of light described by a straight line drawn in the direction of propagation of light is called a ray of light. A broader bundle of light rays is called a beam of light. There are three different types of beam of light. Parallel beam of light. A beam of light where all the light's rays are parallel to each other is called parallel beam of light. And see the diagram of a parallel beam. Convergent beam of light. A beam of light which comes from a broad source of light and converge at a point is called a convergent beam of light, and this is the diagram of a convergent beam of light. Now, divergent beam of light. A beam of light which comes from a small source and diverge out is called a divergent beam of light, and this is the diagram of a divergent beam of light. Light travels in a straight line. The light travels in a straight line, we call it rectilinear propagation of light. While watching a movie, we might have observed a beam of light falling on the screen. The beam of light comes from the projector, shows that light travels in a straight line. Let us perform an activity to show the path of light. Take a piece of rubber tube about 1 meter long and a torch. Fix the torch on a table. Stretch a narrow rubber tube and look through it at the flame. Do you see the light coming from the flame? Now coil the rubber tube and look through it as the flame. Did you see the light coming from the flame? Now the light coming from the flame is not seen. Thus, by this activity, we conclude that light travels in a straight line. Reflection of light. When a ray light falls on a polished smooth surface such as mirror, it returns to the same medium. The bouncing back of the light rays from smooth polished surface or a mirror is called reflection of light. Different materials reflect light to different extent. Silver is one of the best reflectors of light. We can see our image into a mirror due to reflection of light. The surface of clean water also acts as a reflecting surface. We are all quite familiar with mirrors. We use this section. We describe various form self-mirrors, image formation by them and their uses. The reflecting surface mirrors. A smooth, highly polished reflecting surface is called a mirror. There are two types of mirror. Plane mirror. A highly polished plane surface is called a plane mirror. Curved mirror. In curved mirrors, the reflecting surface is curved. The curved mirror are called spherical mirrors or parabolic mirrors, depending upon their curvature. Now, see the diagram or image of the types of mirror. Plane mirror. It is showing a straight line. Spherical mirror. It is showing a curved line. Parabolic mirror. It is showing a sphere. An extra mile. Mirrors change the direction of light that falls on them. Surface of water. Clean water also acts like a mirror and changes the path of light that falls on it due to reflection. A plane mirror, a spherical mirror, and a parabolic mirror are shown above. A plane mirror can be obtained by silvering one side of a glass sheet. The silvered side is then coated with a dark paint, generally orange-red, to protect the silver layer from scratches, etc. This is a picture of a plane mirror in which we see our image. In any mirror, the silver layer acts as a reflecting surface. Change in the direction of light by a mirror. The ray of light which falls on the smooth, polished surface is called the incident ray of light, and the ray of light which gets bounced off or reflected from Smooth polished surface is called the reflected ray of light. The angle between the incident ray and the normal at the point of incidence is called the angle of incidence. The angle between the reflected ray and the normal is called the angle of reflection. Real and virtual images. Real images. The images which can be obtained on a screen is called a real image. Real images are side of the mirror where the object is placed. The images of actors and actresses on the screen in a cinema hall are real images. Virtual images. The image which cannot be obtained on a screen is called a virtual image. Virtual image is always erect. It is always formed behind the mirror. Our image in a plane mirror is an example of virtual image. Lateral inversion. When we look at our own image in a plane mirror, our left side appears right and right side appears left. This phenomena is called lateral inversion. For example, the word red is seen as DER in plane mirror. Image formed by a plane mirror. The image formed by a plane mirror has the following characteristics. The image formed by a plane mirror is erect, virtual, laterally inverted, of the same size as the object, formed at the same distance behind the mirror as the object is in front of it. To verify these properties of the image formed in a plane mirror, perform the following activity. Aim. To study the characteristics of the image formed by a plane mirror. Materials required: a plane mirror, large size. Procedure. Follow the following steps. Stand before a mirror and observe your image in the mirror. Is your head in the image up or down? Obviously, your head in the image is up. That is, the image formed in the mirror is erect. Place a screen in front and behind the mirror is suitable positions and move the screens to different locations. Do you see any image on it? No, the image cannot be obtained on the screen. Thus, the image formed by a plane mirror is virtual. Pick up your right hand and touch the mirror. Which hand does your image lift to touch the mirror? On careful observation, you find that the right appears left and the left appears right in the plane mirror. Thus, the image formed in a plane mirror is laterally inverted. This phenomena is called the lateral inversion. Is the size of your face in the mirror smaller or bigger than the actual size of your face? The face in the mirror is of the same size as your face. It shows that the image formed by a plane mirror is of the same size as the object. Move closer to the mirror. Does your image also move closer? Yes, it does. Move away from the mirror. Does your image also move away? Yes, it does. This shows that the image is as far behind the mirror as the object is in front of it. Conclusion. From the observation made in the above activity, it is proved that the image formed in a plane mirror is erect, virtual, laterally inverted, of the same size as the object, as far behind the mirror as the object is in front of it. Uses of plane mirrors. Plane mirrors are used as looking glasses. They are used for making kaleidoscope and periscope. They are used as reflectors in solar cookers and compound microscopes. They are used to record the observations in some scientific apparatuses such as barometer. Spherical mirror. All the mirrors are not straight line plane mirrors. Even the polished and smooth curved surface can act as mirrors. Such mirrors are called curved mirror or spherical mirrors. A spherical mirror is that mirror whose smooth and polished reflecting surface is called curved surface. Spherical mirrors are of two main types: concave mirror and convex mirror. Concave mirror. A spherical mirror whose reflecting surface is curved inward is called concave mirror. In this kind of mirror, the reflection of light takes place at concave surface, bent in surface of the mirror. And this is the diagram of a concave mirror. Convex mirror. A spherical mirror whose reflecting surface is curved outward is called a convex mirror. In this kind of mirror, the reflection of light takes place at convex surface, bulging out surface of the mirror. And this is the diagram of a convex mirror. Formation of images by a concave mirror. The mirror in which the reflecting surface is concave, depressed in the middle, is called a concave mirror. A concave mirror forms a real or a virtual image of an object depending upon the distance of the object from the mirror. A concave mirror, when placed facing the sun, reflects the sunlight that converges to produce a bright spot. When this bright spot is made to fall on small pieces of paper, they start burning. This bright spot is the real image of the sun. You can study the formation of images by a concave mirror when object is placed at different distances from the mirror by performing the following activity. Aim of the activity: to study the image formed by a concave mirror. Materials required in this activity are concave mirror, focal length is equals to 20 cm, mirror stand, candle, white paper screen. Procedure: follow the steps given below. Mount a concave mirror on its stand and place it on the table. Place a white paper screen in front of it at a distance of about 1 meter. Place a lighted candle at a distance of about 20 cm from the mirror, such that the candle flame and the center of the mirror are the same height and in a straight line. Move the screen to obtain a sharp image of the candle flame. Note down the distance of the screen and the candle from the mirror. Note down the nature of image, that is, if it is real or virtual, erect or inverted, smaller or larger. Observation. Now children, see this observation. What is given in this? Distance of the object candle from the mirror. Distance of the image position of the screen when image is sharpest from the mirror. Size of the image. Nature of the image, that it is erect or inverted or real or virtual. So, conclusion. When an object is placed very near to a concave mirror, an erect, virtual and enlarged image is formed. When an object is placed far away from a concave mirror, the image form is very small. Inverted and real, it can be obtained on a screen. As the distance of the object from a concave mirror increases, the size of the image increases. Ray diagrams for the formation of images by a concave mirror. Case 1. Object at infinity. The nature of the image formed is real. The image is point-sized. The position of image is at the focus of the mirror. This is the diagram which showing the object is at infinity, or when the object is at infinity. Case 2. Object beyond C. The nature of the image is real and inverted. The size of the image is smaller than the size of the object. The position of the image is between C and F. This is the diagram showing object is beyond C, or we can say when object is beyond C. Case 3. Object at C. The nature of the image is real and inverted. The size of the image is equal to the size of the object. The position of the image is at C. This is the diagram showing when object is at C. Case 4. Object between C and F. The nature of the image is real and inverted. The size of the image is larger than the size of the object. The position of the image is beyond C. And this is the diagram showing when object is between C and F. Case 5. Object at F. The nature of the image is real and inverted. The size of the image is highly enlarged. The position of the image is at infinity in front of the mirror. And this is the diagram showing when object is at F. Case 6. Object between F and P. The nature of the image is virtual and erect. The size of the image is larger than the size of the object. The position of the image is behind the mirror. And this is the diagram showing when object is between F and P. Uses of a concave mirror. Concave mirrors are used for many purposes. Some of the important uses are: 1. Concave mirror are used as shaving mirror by men to see enlarged image of face. Women also use concave mirrors as makeup mirrors to see enlarged image of face, such as pointing eyelashes, etc. Second, concave mirror are used as reflectors in torches, headlight of vehicles such as cars, scooters, buses, trucks, trains, engines, etc. to get a strong straight beam of light. Third, concave mirror are used by dentists to see an enlarged image of teeth. Fourth, doctors use concave mirror to produce a parallel beam of light for examining body parts such as eye, ear, nose, and throat. Formation of images by a convex mirror. The nature of the image is virtual and erect. The size of the image is smaller than the size of the object. The position of the image is behind the mirror. Uses of convex mirror. Convex mirror are used for many purposes. Convex mirror are used as rear view mirror or side view mirror in automobiles such as cars, scooters, trucks, buses, etc. to see the traffic coming from behind. Second, big convex mirror are used as vigilance mirror in big shops and stores. Third, convex mirror are used as staircase mirrors on the double-decker buses. An extra mile. The field of view of a convex mirror is much wider than that of a concave mirror. Lenses. A lens is a piece of glass or any transparent material bound with two surfaces, at least one of which is a curved surface. The curved surface is spherical in nature. Lenses are grouped into two main types. Convex lenses. A lens having one or two spherical surfaces such that is thicker at the center than the edges is known as a convex lens. Concave lenses. A lens which is thinner at the center than at the edges is called a concave lens. A convex lens always brings parallel rays of light together and known as converging lenses. It bends parallel rays of light passing through it and converges them to a single point called the focus of the lens. A concave lens, on the other hand, has a property of spreading the light ray. They diverge and appear to come from a point known as the focus of the lens. A concave lens is called diverging lens. Converging and diverging action of lenses. Converging action of a convex lens: when a parallel beam of light passes through a convex lens, it bends inward to meet at one point on the principal axis. See this diagram for your better understanding. Such a point is called the focus or focal point. The inward bending of rays by a convex lens is called convergence or its converging action. Thus, a parallel beam of light rays, after suffering refraction through a convex lens, converges at its focal point. Diverging action of concave lens: when a parallel beam of light passes through a concave lens, it bends outward away from the principal axis and appears to come or diverge from a point on the principal axis. Such a point on the principal axis is called the focus or focal point of the lens. This is the diagram for your better understanding. Please try to understand it. The outward bending of rays after suffering refraction through a concave lens is called divergence or diverging action of the lens. Thus, parallel ray of light after suffering Refraction through a concave lens appear to diverge from a point called the focal point. When the diverging rays are produced backward, they appear to come from the point F, the focal point, on the principal axis. Difference between a convex and a concave lens. Convex, concave. 1. Convex lens is thicker in the middle and thinner at the edges. Concave lens is thinner in the middle and thicker at the edges. 2. Convex lens is a converging lens. Concave lens is a diverging lens. 3rd, convex lens forms inverted and real images for all distances except when the object is placed very close to the lens. Concave lens always form virtual, erect and smaller images whatever be the position of the object. Ray diagrams from the formation of images by a convex lens. Nature of the image formed by a convex lens depends upon the distance of the object from the lens. Some typical cases are described below. When the object is far away from the convex lens, the image is inverted, real, highly diminished. Now see this diagram for your better understanding. When the object is near to the convex lens, the image is smaller, inverted, real. And this is the diagram for your better understanding. When the object is nearer to the convex lens, the image is inverted, real and enlarged. And this is the diagram of it. When object is very close to the lens, the image is real, virtual and enlarged. And this is the diagram of it. Ray diagrams for the formation of images by a concave lens. A concave lens always produces a virtual, erect and diminished image lying very close to the lens. 2 typical cases are shown below. When the object is far off from the lens, this is the image or a diagram showing erect, virtual and very small. When the object is near to the lens, this diagram is showing image virtual and smaller. Uses of lens. Lens forms an integral part of many devices commonly called optical instruments. Some use of lenses are described below. Use of convex lens. Convex lenses are used magnifying glasses. It is used as reading glass to read very small print of a book. Convex lenses are used in making spectacles, cameras, microscope, telescopes, etc. Uses of concave lens. Concave lenses are used in making spectacles for people who cannot see distant objects clearly. Concave lenses are used in certain types of telescope. Colors of light. Take a transparent ruler and hold it in sunlight. Adjust its position a little till you see a hue of various colors. Notice carefully the white sunlight has been split into 7 different colors. You can also see colors in the sky in a rainbow formed after it has rained and the air is still laden with moisture. The sunlight of passing through the droplets of rain forms a band of colors which we call a rainbow. This phenomenon of splitting of white light is called dispersion and the band of colors is called a spectrum. The 7 colors in the spectrum of white light are violet, indigo, blue, green, yellow, orange and red, known as Vibgyor, as you seen in the diagram. You can observe the spectrum around a fountain or water spray and also when light passes through a prism. A prism is a piece of a transparent material bound by 2 triangular and 3 rectangular surfaces. Newton's color disc. Newton's color disc is a disc of cardboard or metal which is divided into 7 sectors which are painted in the colors of Vibgyor. When the disc is rotated very fast, it appears almost white. This is because the image of each color on the retina does not get erased before the image or the other color forms on it due to the fast movement of the disc. This phenomena is called persistence of vision. The reason why color on the disc does not appear exactly white is because the color on the disc are not exactly like the color in the natural spectrum of light. Now it's time for Reader's Digest. A highly polished plane surface is called a plane mirror. In curved mirrors, the reflecting surface is curved. The image which cannot be obtained on a screen is called a virtual image. The image which can be obtained on a screen is called a real image. A spherical mirror whose reflecting surface is curved outwards is called convex mirror. A lens is a piece of glass or any transparent material bound with two surfaces, at least one of which is a curved surface. So students, it's time to take your leave. Bye. We'll meet in the next class.